Hey learner, ready for a deep dive into something really cool? We're talking artificial intelligence today, specifically how computers are learning to understand language, like you and me. And get this, it's all about attention.
It really is. We're about to unpack this groundbreaking paper, Attention is All You Need. It completely revolutionized machine translation.
Transformed it. Okay, before we get ahead of ourselves, let's back up a bit. How were computers learning languages before this paper came along?
Imagine the human brain, processing everything step by step, one word at a time. That's basically what computers were doing with something called recurrent neural networks, or RNNs. It got the job done, but it was slow.
Okay, so RNNs were the slow and steady learners. Then came the transformer, right? It's like the super speed reader of AI.
You got it. The transformer was the first model to ditch this whole step-by-step thing. Instead, it relies entirely on attention.
Okay, I'm intrigued, but also a little lost.
Yeah.
What does attention even mean in this context?
Think about it like this. When you read, you don't pay attention to every single word equally, right? You focus on the important ones, the words that really give you the meaning. That's attention zeroing in on what matters.
So it's like scanning a news article. You're looking for key facts, not every single word.
Exactly. And the transformer, it allows machines to do the same thing with language.
That's pretty wild.
Yeah.
So how does it actually work? This paper mentions scale dot product attention. And honestly, that sounds a bit intimidating.
It sounds complicated, but it's not that bad. Imagine you have a question that's your query, and then you've got all this information. Those are your keys and values. The keys, those are like labels that help you find the right value, the right piece of information. The dot product, that's just a mathematical way of figuring out which value best answers your question. Or query.
So each word is scored based on how relevant it is to other words.
Bingo. And here's the cool part. The transformer doesn't just have one focus. It has multiple attention heads, each looking at the sentence from a different perspective.
Multiple attention heads. So instead of one person trying to understand, it's like a whole team, each looking for different clues.
Exactly. One attention head might be all about grammar, while another is focused on the meaning. And yet another one, maybe it's looking at the context of the entire sentence.
This is mind-blowing. So
Hmm.
we've got these attention heads making connections, but RNNs, they were processing one word at a time. If the transformer isn't doing that, how does it keep track of the order of words? That seems important for, well, understanding anything.
Excellent question. And it highlights a key difference. See, because the transformer isn't going word by word, the creators needed a new approach. They came up with something called positional encoding.
Okay, positional encoding. Is that literally like putting a sticky note on each word that says, I'm number 3?
It's more like giving each word its own special signal. This tells the transformer where it fits in the sentence. The paper, it uses something called sine and cosine functions.
Sine and cosine. Like trigonometry from high school. What does that have to do with language?
Right. It seems strange, but it's incredibly effective. These functions, they create a pattern that the model learns. It recognizes the pattern as representing different positions in the sentence.
So it's like teaching the AI the concept of word order, not just specific examples. That's brilliant.
Exactly. It's way more adaptable than just assigning numbers to words. And honestly, this is just scratching the surface of what makes the transformer so remarkable.
This is all starting to click, but I'm still stuck on the why. The paper mentions the transformer is faster, more efficient. But how does attention make that happen?
Well, think back to those RNNs, processing everything step by step. You couldn't even start on the next word until you were done with the one before.
Like waiting in a really, really slow line.
Exactly. The transformer is like everyone's at the buffet at the same time, no waiting.
So the transformer processes all the words at once.
You got it. Much faster, especially for longer sentences. In fact, the paper says it really cuts down on the number of steps needed.
And fewer steps mean less training time, right, for the AI.
Exactly. Less time and less power needed. We can build more powerful AI without needing, like, a whole power plant just to run it.
That's a win for everyone.
Yeah.
Okay, so the transformer is obviously huge for translation, but the outline mentioned it's being used for other things too.
Oh, absolutely. It's been revolutionary. The paper actually talks about this, something called English constituency parsing.
Which is,
Imagine teaching a computer to diagram a sentence. Find the subject, the verb, the object, all the pieces and how they fit together. It's about understanding the grammar, not just the individual words.
so not just translating anymore. It's about understanding how language works, My mind is officially blown.
And the amazing thing is, the transformer was incredible at this too. Even better than models designed just for parsing.
We've gone from zero to AI whiz kid in like 15 minutes. Okay, before we get too carried away, let's bring it back to our listener. Why is this attention is all you need paper such a big deal? So, to recap, we've learned that the attention is all you need. Paper. It introduced the transformer. Totally new way to build AI. All about attention, no more clunky RNNs.
Right. Attention gives the AI superpowers. Focus on the important stuff, understand how words connect, even learn the rules of grammar.
And it does it all faster and more efficiently, meaning even more powerful AI is coming.
Exactly. This wasn't just about better translations. It changed everything about how we approach natural language processing. Things like summarizing text, answering your questions, even writing computer code.
It's like this paper opened a secret door in AI research, and everyone's running through to see what's on the other side.
That's a great way to put it. And what's even more exciting is that the transformer, it's just the start. The paper itself even hints at this more powerful models handling different types of data images, audio, all using attention.
So what you're saying is, this deep dive, it's just a taste of what's to come. The future of AI is all about attention.
That's what I think, yeah. And that's something I really want our listener to think about. What happens when AI can truly understand the world? Not just words on a page, not just what we're saying, but all the nuances, all the complexity.
Now that's something to ponder. Okay, so we've spent a lot of time on the nuts and bolts of the transformer, but I think it's time we really brought it home for our listener. Why is this paper, Attention is All You Need, considered such a turning point for AI?
It's a great question. You see, before this paper, machine translation was okay. I mean, it worked, but it always felt like a machine was doing it. Does that make sense?
Because it couldn't really understand what it was translating. It was just matching words, not understanding the meaning.
Exactly. The transformer changed that. Suddenly, machines were translating with, like, near human accuracy, even better than humans in some tests.
So what you're saying is more accurate translations for everything, from reading news articles to, like, doctors in other countries understanding patients.
Exactly. Huge implications. And remember how we talked about the transformer understanding grammar? That English constituency parsing thing?
Like it was diagramming sentences.
That ability to see the structure of language, that was huge. It meant AI could start doing much more sophisticated things.
Like what? Give me an example.
Think about chatbots. Before the transformer, they were so clunky, just giving those pre-programmed answers. But with a deeper understanding of language, they could actually have a conversation.
Hold on, so you're saying instead of just spitting out canned responses, they could actually understand what you're asking and give a real answer.
You got it. And it's not just chatbots either. We're seeing the impact of this paper everywhere. AI summarizing huge documents into something you can actually read, answering complex questions.
It sounds like this one paper really did change everything.
It did. And honestly, it's still early days. The transformer is incredibly adaptable. Researchers are finding new ways to improve it, use it for new tasks, even combine it with other AI approaches. It's really remarkable.
So to wrap things up for our listener, this deep dive was a peek into the future of AI. And that future is all about attention.
That's my takeaway, yeah.
Yeah.
If we want to build truly intelligent machines, machines that don't just process but understand, attention is key. The ability to focus on what matters, to connect the dots, to grasp the nuances of language. That's what makes us intelligent, right?
That's a powerful thought. As we finish up, think about that. What if AI could understand the world the way we do? What would that look like? The possibilities are pretty mind-blowing. It may be a little bit daunting.
No doubt. But it's going to be an amazing ride.
And on that note, we'll wrap up this deep dive. We hope you've enjoyed this journey into the incredible world of AI and attention. Keep those brains firing, keep exploring, and until next time, stay curious.